Working with an equation, it was like that. Okay. But here's the basic question is, if R stays the same and V increases, what happens to I? R stays the same, V increases, what happens to I? Does it get bigger or smaller? Okay? Turn to your neighbor and just talk about it for 1 minute, and then let's touch bases. Okay, let's come back together again. Arlene, is you willing to take it on? Arlene thinks it goes higher. So R stays the same. V increases. What happens to I?
How was I thinking? If R is equal to 2, okay, think of something a little bit simple.
Good.
Okay, and that stays the same.
Okay.
Again, I put 1 on top.
Okay.
That is 1/2, right?
Yep.
2 stays the same, and I change the top to 2, and that goes to 1. And then I go to 3, and that goes higher, 1.5.
So every time this number increases, what happens to I then? I is the number you're creating, right? So are the numbers, is this?
That was the only one number I used, so I'm sure like integers or negatives might affect it.
Is it getting bigger though?
Yeah.
So do you agree with her? Is 3/2 bigger than 2/2? Is 2/2 bigger than 1/2? I want you to notice her strategy. Can somebody reflect back on how she solved that? What was her strategy to solve that? Yes,
She
Joanna.
put numbers to
Okay.
take the place of those variables.
Okay, what happened when I put in variables and I looked around and I saw this? What happens when she put numbers in? Common core, yeah. Okay? This is something I want you to write down in your notes right now. We need to use numbers a lot with students and applications, contexts. Like, let's use real numbers and real problems to help them make sense of this stuff. This is a strategy. When I was a high school teacher, my students, every year, 9th grade, they'd come in, and I'd give them something like, similar thing, with lots of letters, and they'd just be like, you'd see their pencils drop, and they were like a deer in a headlight. Strategy. The toolkit. All right, everybody, let's pick up your pencils. I want you to start putting numbers in. Oh, okay. We need to be able to make sense of these things, right? So this is a thing. You can start now with that. Math is something we can make sense of. Everybody, turn to your neighbor and say, math is a sense-making activity. How do we make sense of math? Does it make sense if I use a bunch of letters all the time? When I use lots of letters, a lot of us in here, it gets ugly. People start, it's daunting. You start to tip over your chair. Everybody's snoring. But we bring in the numbers. We bring in the really expensive coffee. It's happening, right? I want you to reflect on how you feel right now when we use numbers. Math is a sense-making activity. You ready? We're going to do one more. I'm doing this for a reason. It'll make sense in a minute. Let's do it again. Same relationship. Okay, you ready? What happens to I? Okay, this is going to be a really hard one. You ready? See, I'm setting this up. It's going to be super hard. You ready? Really, really hard. All right, I is decreasing. I is decreasing. V is increasing. What's happening to R? Okay, so I is decreasing. V is increasing. What's happening with R? This is a hard one. I'm challenging you right now. See, so if I'm the teacher and I say it's really hard, how do you feel right now? Like maybe you're going to stop, right? So I did that on purpose, just to, maybe it's not such a good idea, huh? I should just say, you can, come on, we're going to figure this out. I is decreasing. So the numbers, see how when Arlene set this up, she showed us that's it's increasing. We want those numbers to be decreasing, getting smaller from left to right. How did Arlene solve it for us? What did she do? She put in numbers. Okay? Now, I don't have any numbers that stay the same this time. So we've got to be sort of playing with it a little bit. Ben, could you share your strategy? He has an interesting approach on this one.
Oh, well, let's see. I just reasoned that if I is decreasing and V is increasing, R has to be also getting larger so that the fraction V over R is also decreasing. And then you made the point that V and R can't be the same.
What do you guys think about that? Would it help to try numbers? Okay. Can we generate some, and Arlene, I want to look at your strategy in a minute. Can we generate some numbers? Ben, did you have a few examples to help us?
No, I didn't have any numbers.
Okay. Yvonne, you had one example.
Well, for I had 5. I put 5 equals 10 over 2.
Wasn't that your second one, though? I think
My second one was 4 equals 12/3.
But I think that would be your first one because V has to decrease. Sorry, I is decreasing. So you go from 5 to 4.
Yes, 5 to 4.
Okay. That's right. So it was 5 equals, what was it?
10 over 2.
10 over 2? Mm-hmm. What was your second one?
4 and 12/3.
All right. So let's see if it works. I is 5 equals 10 over 2, 10 halves. That's your V, that's your R. Now I'm saying I is decreasing, so 5 has to decrease, so it did. She went to 4. Is everybody with me? 5 to 4, I is decreasing. V is increasing, so 10 has to increase. She did that. It goes from 10 to 12. What had to happen then to her R? It had to increase too. It has to increase fast enough to keep up with this number as it increases, and even sort of it has to go up faster at a faster rate, basically. Okay? Now, here's the thing. Notice if you're challenged right now, it's because I just found a threshold of understanding. Some of you right now, I can see it, your faces are a little bit like, I'm thinking about this, right? This is why we want to give these types of things to our students. Okay? Notice that we are developing a type of thinking here. It's the exact same type of thinking that Casey's developing with his students right now in 3rd grade. I'm having to think multiplicatively. It's actually, I'm using this type, it's a relative multiplicative way of thinking. It's not additive anymore. Additive was when we looked at this and we said 3. There's 3 reds. This new way is, oh, there's 3 sevenths. Oh, I have to do what again? Okay, notice I'm working with a fraction here. How do I change the fraction? I have to think about size. I have to think holistically. So both of these examples, notice this one was a little easier to hold on to because one thing was constant. So if you want to ratchet it up and make it a little harder, the 2 things that you give are changing. But anyway, you can play with these and just keep playing with them. These are fun ones to do as you're walking down the street in Albuquerque. You're on the way to the state fair. Okay, I is the same, just play with them. It's really good, and you can give them to your kids as they're going out to the playground. Something like this, just play with them. Yes, ma'am.
Okay, so I understand 5 is the I, and that's going to equal 10 halves. And then 4, then I is going to decrease, so decrease it by 1.
4
It should be
decreased.
4.
Yep.
and then it'll be, that equals 12/3. But then if you go to 3, then what?
So the 2 to 3, it increased. So notice that V, which is right here, so I specified at the beginning, I said I is decreasing. And Ben met, or in this case it was Yvonne had the example. She went from 5 to 4, so she met that. And then V had to increase, so 10 has to also get bigger, it goes to 12.
Okay, so you're just jumping by 2s.
Notice she just made this up. Yeah, she just made it up. So she worked with easy numbers. That's a really good strategy. And then I think probably she thought about it. She thought, okay, here, I don't know how you did it, Yvonne. Maybe you did this one first, and then you said, well, I'm going to decrease that to 4, and then I put it 12. And then you had to figure out what number that would be to make it work. Is that right? Okay. So she just did the math, I guess, figured that out. And then you notice, oh, R had to increase. And that's what Ben was saying. This number has to keep increasing pretty fast. It's going to have to go up at a faster rate than V. Actually, here's something, Kathy, I'm going to use. I hope this makes sense.
Okay. Well, I'm just trying to find a pattern, if there's a pattern.
There's not.
There's not.
There is sort of, and there isn't in a way. Here's the pattern. I'm going to challenge you as a relative thinker. You ready?
Oh, okay.
Here's a relative way to think about it. You ready? Going from 10 to 12 is not much of a change. An absolute thinker would say that's just going up by 2. A relative thinker would say that's going up by 2/10. Yeah, how do I get 2/10? My whole is 10?
Yeah.
I'm just increasing it by 1/5. Not going up. I'm not increasing the number very much. The rate of change is very little. See, this is the relative way of thinking?
Yes.
How much did we increase, though, when we went from 2 to 3? Well, we went up by 1. That's the absolute way of thinking. 1 is less than 2, but the relative thinker would say no. We increased by 1/2 the number we started with. 1, what's the whole? 2, we went up by 1/2 of the original number. 1/2 is more than 2/10. R had to increase at a faster rate. It has to increase at a faster rate than V for this to work. And Ben, that's what Ben was telling us. R has to increase at a faster rate than V for I to go down. Notice that's a relative way to think. It's a multiplicative way to think. It's a more sophisticated way to think mathematically. Yes, sir.
If you had R as a negative constant, would that apply to this?
Hey, somebody over there thought about that. You want to give us your example?
The original one that I have that says 1/2, 2/2, 3/2. I just put a negative in front of the 2, and it worked. If I decrease, the V is increasing, and the R stays the same.
So you're saying the V is increasing from 1 to 2, 2 to 3. What happens to I from here to here to here?
I decreasing.
So is this number bigger or smaller than this number?
Smaller.
Negative 1/2
Oh, pardon me.
compared to negative 1.
1. Half. Is negative.
So on a number line, anybody want to show us the number line? We need to see where these 3 numbers lie in relationship to each other. I'm going to do it right here. Somebody want to come up and show us? Okay, so we've got 0. I want somebody to, here, I just blew the number line. Let me do it again. Now, and here's a question, by the way. Are these, is this an equivalent representation of what I have up above? This is actually a question sometimes we get tripped up on. Is negative 1/2, is that the same as 1 over negative 2? Are these equivalent fractions? Are they the same? Yeah? We did this in the summer, I think, didn't we? Everybody comfortable that they're the same? I can move the negative sign to out front in the fraction, or I could put it in front of either of the two numbers in the fraction. Okay? Are you sure you're comfortable with that? Let's just take 1 minute to do that, and then we'll come back to our number line. So, question. Is this equal to this, and is that equal to that? You see what I'm doing? Are they all equal to each other? Think of it in terms of a quotient. If I take -1 divided by 2, does that equal 1 divided by -2? If we divide a positive by a negative, is that equal to a negative divided by a positive? You see how I'm just playing with? As long as we have a negative and a positive, we get a negative fraction, right? A -1 divided by +2 is equal to a +1 divided by -2. Because we have a positive divided by a negative, negative divided by a positive. When we do that, we always get what? A negative number. You with me? Okay. All right, so we're comfortable? So what Arlene said was, you had a half, and then you had 2/2, and you had 3/2. You just put a negative sign in front of the 2's, right? Now for her idea, her conjecture to work, right, these numbers have to be decreasing. Didn't we say I had to be decreasing? These are her I's, okay? Is everybody with me? If they're decreasing, then on the number line, this number should be what? To the left or right of this number? If they're decreasing.
Left.
Okay, so if we're saying these are decreasing numbers, on a number line, then decreasing means moving to the left, right? So on a number line, notice again, this is the visualization image piece that Lorenzo keeps reminding us of. We can visualize this. As numbers get smaller, they move to the left on the number line. They're to the left of each other. Is that right? Okay, help me then figure out where are we going to put these numbers on the number line? Where are they? They're all negative, right? So they're to the left of 0. Is that correct? Okay. All right. What's the next number then we want to, if we're moving to the left, is it going to be -3/2 or -1/2? We sure about that? Why? Okay, how come, Thor?
How come what? How come it's going to the left, or is it the first one?
Yeah, how come it's the first one?
It's the smaller of the other two. I mean, that's where we're starting from.
Smaller or larger than the other two?
Well, larger, yeah.
Okay.
Going in
closer to one.
going in the negative direction.
Closer to 0 or closer to -1?
Closer to 0.
Okay, what would be next then of the 3? Okay, -2/2, which is the same thing as -1. Okay, and then what would come next? So question now, is Arlene correct or not?
Yes.
Were the numbers getting smaller? As she went this direction, are the numbers getting smaller? Is this number smaller than this one? Can we see it? It's to the left of it on the number line, so it must be smaller. Is this one to the left of this one? Yes. So we're getting smaller as we move. So her conjecture, who can now state Arlene's conjecture, what she did and to make this work? She did a lot. I had no idea, by the way, we were going to do this. This has been really fun. Guys, this is hard. You guys did this. This is hard. I had no idea we were going to figure this out. Okay? So I is decreasing, V is increasing. What has to happen to R? So what did she discover? Somebody want to put it in your own words? Say it again.
She made R negative.
That's it, and it was still constant, right? But it was a negative constant number. That's pretty cool. And how'd she do that? You probably played with the numbers again. Yeah.
And she's number 1.
Is it okay to talk about improper and mixed numbers at this point, or would you?
Sure.
I mean, right away I saw that it was improper. So when it's improper, you're going to have a whole number next to the fraction.
So here's the thing. So this was a lesson I saw yesterday in a high school classroom. Okay, so it was high school level.
On a number line, you can see it better when it's in a mixed number. I mean, if we do 3 over 2, while you're going
like
towards,
this?
yeah, so you're at 1 already.
Right.
And if you have the 1 as a mixed number, you're at a half, going from, negative 3 over 2. So it'll be -1 and then another negative half.
Uh-huh.
So I was just wondering if that's going away from the multiplicative thinking, or is that something that you want to work together with?
Yeah, I think if I understand what you're saying, and correct me if I'm wrong, that basically we want children to be thinking about number, fractions, and we want them to be thinking about them in different ways. And so what I like here about this, and you can really see it actually, you can really visualize it, is that when we have, so this is kind of cool. If we cover up the negative signs, right? We have a half, and we have two halves, and we have 3 halves. As the numerator, without the negative sign, as it's getting bigger, right? It's moving to the left. And so there's something there, there's a pattern there. And so by using improper fractions, we saw that. If we use mixed numbers, we wouldn't have seen that. I don't know if that addresses what you just brought up, but it's a pattern. This is a pattern. So this is something that I want you to see, I think, as a strength in your children, because I guarantee it is. Patterning. Patterning. Your kids naturally like patterns. They see them. They like to bring them up and share patterns that they see in their lives, patterns that they're noticing, right? Oh, my little sister always does this, right? Maybe patterns in artwork, patterns in things they see in the home, whatever it is. This is a pattern that children are going to be intrigued by, just like we are, right? We're all kind of like, wow, there's a mathematical pattern there. We could create some kind of a beautiful mosaic probably now, with colors and stuff. You guys are the artists. I'm limited. But anyway, I bet there's a lot of beautiful patterns here. I see a pattern, and I would love for my class to write what it is now and see if they could, in words, and Lorenzo's been doing, I know a lot of this, write it out. What's the pattern you see right now? That would be beautiful, I think. This is what makes math so much fun, all the patterns. It's incredible. I probably didn't answer your question.
I think it's good, like you said, for them to see it on that way, especially when I'm thinking back to the question that we had on the pretest was 13 fifths.
Yes.
So how I did it on a number line was right away, I changed the improper fraction to a mixed number.
Okay, that's
so
fine.
it came out to like 2 3/5.
Mm-hmm.
So on a number line, I was able to look at that and then break each part of those
That's a good
smaller parts
strategy.
into 5s.
That's a great
So you can
strategy.
see the 13 fifths as well too.
Notice that when I use improper fractions, it's really easy to see it. And we're going to talk about that in just a minute. But thinking about fifths, it's not just 13 fifths, it's 13 fifths. I can take a fifth then and just put together 13 of them, and suddenly I see 13 fifths. Isn't that a cool way to think about fraction? It's 13 of those fifths. Yes, ma'am.
I wanted to say also, isn't this leading more towards Common Core, where we see the pattern and we're able to explain it?
Yes.
How did we get that answer? So.
Yes, and so here's one of the things about math being a sense-making activity is we start to make it into these patterns that are comprehensible, okay? Math is patterning. Math is art. Math is creative. Math is something we can create something that's beautiful, like a beautiful quilt that has patterns in it, geometric design. One of the things that has become a big part of the standards is designing, patterning, visualizing geometric patterns, because geometric patterns are also algebraic, they're arithmetic. All these things are connected. We want math to be connected, okay?